Let us take the second question. Here I am marking this question. Let's see what is given here. Draw SFD and BMD for the beam as shown in figure. Here they have given some diagram, and based on this diagram we have to draw the shear force diagram and bending moment diagram. So now let us start this problem. That is question number 2. I'll write the solution for this. In the solution, first the beam has to be drawn which is given. Now this is the beam which is given in the question. We have to find out the shear force diagram and bending moment diagram. First of all, I will write step number 1. And in step number 1, it is calculation of support reactions. So here I have reaction at A, I will call it as RA. Reaction at B, RB, both are upwards, so therefore I have RA plus RB minus 3 minus 5 2 into 3, that will give me 6, and it would be acting downward. Minus 6 is equal to 0. So therefore RA plus RB, this would be minus 14. If I shift it onto the other side, that becomes plus 14. I will keep this as my equation number 1. Next, after calculation of support reaction, the first point I'll say that this was summation of Fy is equal to 0, because sum of all vertical forces are 0 for the equilibrium of the beam. Now, summation of moments of all forces about point A would be equal to 0, where clockwise moments positive and anti-clockwise moments negative. So therefore, here as we see, if I take the moment at point A, RB is upward, moment would be anti-clockwise, so it would be minus RB into the distance 7. Then 5 kilonewton is acting downward, so it would be producing clockwise moment, so plus 5 into 5. 3 kilonewton is producing clockwise moment, so plus 3 into 3. 2 into 3, that is 6 kilonewton acting at 1.5 meters, that is half of 3, so plus 6 into 1.5 is equal to 0. Therefore, from this, if I calculate all the terms here, this would be 25 plus 9, and again this term is 9, so it is 25 plus 18, that is 43. If I shift it onto the other side, it becomes minus 43. Negative negative cancel, 43 by 7, so RB is 6.14 kilonewton. After this, I will say that put RB in equation number 1, and so I will get the value of RA. Put RB is equal to 6.14 kilonewton in equation 1. So therefore RA value will be 14 minus 6.14, and that comes out to be 7.86 kilonewton. So I have calculated RA and RB values. After getting the first step, now I would be going on to the second step, that is calculation of shear force. So step number 2 is SF calculations. Here I will start with point A, that is SF at point A. it will be equal to, I will be taking the section just to the right of A, my section is here, and as per the sign convention, upward force to the left of the section, downward force to the right of the section are positive. Downward force to the left of section and upward force to the right of section are negative. So SF at point A, if I see this, here I have section and to the left of section I have upward force, so that has to be taken positive. So it is plus 7.86 kilonewton. That is positive. Next, SF at point C, here I would be having two values of shear force at point C. For the first value, I will be taking section to the left of C. So if I see to the left, I have RA as upward and this 6 kilonewton would be downward. So RA minus 6, that is 7.86 minus 6, that gives me 1.86 kilonewton positive. Then again I will write down shear force at point C, that will be equal to, for that I have to take the section just to the right of C, and that would be 7.86 minus 6 minus 3. That comes out to be minus 1.14 kilonewton, that's negative. Then I would be calculating SF at point D is equal to, I am taking the section just to the right of D, so it will be, to the left of the section I have 7.86 upward, 2 into 3, that is 6 in the downward direction, then 3 is also downward to the left, so negative, 5 is also downward to the left, so negative. Hence here I get the value as minus 6.14 kilonewton, that's also negative. After this I am left with just point B, so SF at point B, for that I will be taking the section just to the left of B, and if I see here, to the right of this section I have RB which is upward, so it has to be taken positive as per the convention, so it would be negative. To the right upward section has to be negative, so here I have minus 6.14 kilonewton as negative. With SF calculations available, now we can draw the shear force diagram, and for that we have to draw the beam again. So here I would be drawing the diagram of the beam which is given in the problem. This is the beam diagram. Now I would be projecting points A, C, D and B downward, starting with point A, point C, point D, and point B. Now first, for drawing the shear force diagram, the length of the beam and the length of the shear force diagram, they should be equal. The length of shear force diagram should be equal to the length of the beam. Now at point A, I have SF value as plus 7.86. At point C, I am having two values, one is positive, one is negative. The positive is 1.86. Negative value is minus 1.14. Then at point D, I have value as minus 6.14. And this would be constant up to point B. Now for drawing shear force diagram, since there is UDL between A to C, so shear force diagram would be an inclined line. Then the load decreases from 1.86 to minus 1.14. Between C to D, here we don't have any load, so SF would be straight line, and then at point D the value is 6.14 kilonewton. Next, between D to B there is again no load present, so SF should be a straight line. Now this is the shear force diagram which we have. Whatever I have plotted above the line, that is positive, and below the line, that is negative. So this is the shear force diagram which we have. Now below this we would be drawing bending moment diagram, but before that we have to write down bending moment calculations. So I'll write down step number 3. That is bending moment calculations. Here I'll say that moment at A is equal to moment at B is 0, because here they are simply supported. Then moment at C, it will be equal to, for moment at C, my section would be at C. To the left I have RA, which is upward, and 2 into 3, that is 6 kilonewton, and I have to draw the sectioning. So here first I'll show you the sign convention. Clockwise moment to the left, anti-clockwise moment to the right are positive. Anti-clockwise moment to left and clockwise moment to right, they are negative. So therefore, if I want to calculate moment at C, my section would be at C, and to the left I have RA, which is 7.86 kilonewton. This would be producing clockwise moment, so it has to be taken positive. 7.86 into 3. Then here I have 2 into 3, which is 6 kilonewton, acting downwards, so producing anti-clockwise moment at point C. So that is 6 into half of 3, that is 1.5, minus 6 into 1.5. Therefore moment at C, the value comes out to be 14.58 kilonewton meter. Next, moment at D, that is equal to, here if I see, if I take the section at D, to the left I have 1, 2 and 3 forces. To the right I have only one single force, RB, that is 6.14 kilonewton, and it produces anti-clockwise moment to the right, so it has to be taken positive. So here I have plus 6.14 into 2. So the moment at D is 12.28 kilonewton meter. So with these values of bending moment available, we can easily draw the bending moment diagram. The length of bending moment diagram should be equal to the length of the beam, and it should be drawn below the shear force diagram. Point A, C, D and B. Here A and B, moment at A is equal to 0, moment at B is equal to 0. At C the value is 14.58 kilonewton meter. At point D it is 12.28, which we have found out. Now, as we see, between A to C there is an inclined line because of UDL in shear force diagram. So bending moment diagram should be parabola between A to C. From C to D there is straight line in shear force diagram. So in bending moment diagram there should be an inclined line. Again, between D to B there is straight line in shear force diagram. In bending moment diagram it should be an inclined line. So here I'll say that it is a parabola from A to C. Here I have point C, point D and point B. All the values are positive. And as we see here, the point where shear force is changing its sign, shear force is 0, and at that point the bending moment is maximum. So here I have completed the bending moment diagram, and as they have told in the problem, we have to calculate shear force and bending moment diagram, and we have given them shear force and bending moment diagram. With this the problem gets completed.